Good afternoon and welcome to the audience to, I think, a very important webinar dealing with zero trust and President Biden's executive order urging our agencies, government agencies, to adopt zero trust. What we are here today to do is discuss in this important webinar why is zero trust first and foremost being asked for? What propelled President Biden and the National Security Agency to ask for the adoption of zero trust? The second question that we will try to answer is, what is actually zero trust security? It's not a term that's familiar to most other than experts. And third, many are joining us because they wish to understand the relevance of zero trust to compliance programs that are currently underway, such as CMMC, ITAR, NIST 800-171. How does zero trust directive impact those programs? How are aspects of zero trust built into it, etc.? And then finally, we recognize that the topic of zero trust, and particularly the presidential mandate, is a very large and complex undertaking. It has implications on policy, it has implications in compliance, security, and the law. And all of these topics will be addressed by our panel of experts. To share with you a bit more about what is zero trust, we have Professor Raluca at Popa. She's a computer security professor and one of the world's top cryptographers and security experts. She's a professor of security at UC Berkeley, co-founder of Prevail. She won the best thesis title and award at MIT, where she got her PhD. She recently also won the 35 under 35 Distinguished Award from the Massachusetts Institute of Technology. To share with us insights into the policy, compliance, and legal aspects of zero trust, we have one of the nation's leading cyber attorneys, Bob Metzger. Bob's the practice lead for cyber at RJO. He is the author, or rather the co-author of MITRE's Deliver Uncompromised Report. He leads RJO's national practice, but above all, is deeply immersed in topics of security, as they pertain to supply chain. So these are our two main speakers. I'll be adding a little bit of context. My name is Sanjeev Verma, chairman and co-founder of Prevail. So welcome, Raluca and Bob.
Thank you.
So let's first delve into the notion of what are the drivers for zero trust? Why a presidential executive order? Well, I think most people have heard of the attack on the US government infrastructure through SolarWinds, and this is one of the very fundamental drivers. So what happened over here was a fundamental breach of the most sensitive government agencies. So it is a breach that impacted many, but most importantly, the Department of Homeland Security. And to get a taste for the impact of this, the emails of the Secretary of the Department of Homeland Security were compromised. So were the emails and files pertaining to the DHS officials whose very responsibility was to identify foreign threats, and those too were compromised. And again, these are coming from the Associated Press. A second and more equally important attack occurred, which was on Microsoft Exchange servers. This was a direct breach of Exchange servers, particularly on-premise Exchange servers. And again, once these servers were breached, the attackers had full access to email, passwords, access to admin privileges, and it impacted 250,000 servers and 30,000 organizations. So clearly, we saw an important and very significant breach. And since most organizations in the government and the private sector operate on systems like these, it showcased the significance of the magnitude of the attacks that could occur. So in response, The National Security Agency in February issued a directive first to the Department of Defense to strongly pursue zero trust. And then President Biden followed up with a directive to strengthen the nation's cybersecurity through his executive order. But what is zero trust? The NSA actually did a really nice job of defining it. And why do we go to the national
Sanjeev, just to sort of, if you don't mind, let me jump in for a second,
Sure.
because you've had an excellent way to start.
Yeah.
So there's no question that SolarWinds led to the executive order, and it's also forcing attention and priority to zero trust. But the nature of the attack in SolarWinds allowed adversaries to get inside or to conduct reconnaissance and get inside many networks. And once, past the perimeter and inside the network, the opportunity for lateral movement could be largely unrestricted. And when there is lateral movement, the adversary is not only inside, but it can stay inside, and it can be, in a posture where it's extremely difficult to find the adverse code that could be exploited later on the command or under the control of the adversary. And so, if you understand zero trust to tell you that you shouldn't trust anything or anyone, and if you understand zero trust to mean that your perimeter has already been breached and the adversary is present, and if you understand SolarWinds to mean that executive branch agencies as well as key organizations were the subject of exactly those attacks and face those continuing risks, well, then it's pretty easy to understand why zero trust goes from being an important ideal to a high priority. Because if a federal network already is compromised, then the perimeter defenses are beside the point. They are too late, and the threat is going to execute from inside out. And so for that reason, zero trust is getting emphasis. It's not just to protect against new attacks, but it is to identify, react, respond, recover, minimize, and report on execution of hostile code that is already inside a federal network or an organization.
Very well put, Bob. And I think you made my job easier to again say what the NSA said, which is you articulated very well that, look, traditional perimeter-based network defenses with multiple levels of disjointed security have proven themselves unable to meet the cybersecurity threat. The zero trust, and I am going to repeat this 2 times, eliminates trust in any element, node, or service by assuming that this breach is inevitable or has already occurred. And I repeat.
I'll jump in again. So, I mean, the focus in the NSA definition, of course, is on focusing, the networks of federal departments and agencies. There's a little bit less recognition than perhaps we want to talk about devices. In other words, it's not just that you want to protect the network itself from the X outflow of information. You also want to protect the network insofar as its functionality relates to operational systems or technology. But you also need to recognize that access to network is so different today than it once was, where we have a remote and distributed workforce, where we have endpoint devices of so many kinds and varieties. And looking ahead to the future, where we have IoT type devices connected through 5G extremely high-speed networks, you have a situation where the traditional approach of looking at the network, controlling access to it, is simply overwhelmed by numbers, by technology, not to mention bypassed or overcome by threatening actors.
And again, absolutely right. And I think that the definition that the NSA gave was not just for the networks that you rightly pointed out, but eliminating trust in any element, node, service, or device is what they emphasized. And that's really where, Professor Popa is going to go and add more color. But the key is that while perimeter systems today assume that they will be able to protect against the adversary getting in, etc., the end of the definition of zero trust and what you articulated so clearly, Bob, is that assume that a breach has occurred or is inevitable. And again, analogies are hazardous, but I want to give for many who are not practitioners of cybersecurity a simple analogy that a perimeter defense system you could think of as a mask that is designed to keep an attacker out. But no matter what the virus is going to get in, a zero trust assumes that the virus is going to get in. And so vaccines are an analogy for how a zero trust system operates, in which it basically assumes that the attacker is going to get it. Now, the analogy is a rough one. What we want to be clear is that in a zero trust system, we aren't saying get rid of the perimeter defenses. What we are saying over here is that the perimeter defenses are necessary, but assume that they will be breached and find systems that will essentially protect information, access, etc., even when the breach occurs. So with that, off to Professor Popa to give us, again, in both simple but precise terms, exactly what is zero trust and how does it contrast to the way in which we deal with security today. So Dr. Popa, over to you.
Yeah, thank you. I can share my screen right now. I presume you can see my screen now. Yeah, great. Well, hello everyone. Really glad to be here and be talking about this very important topic. I really wanted to add to the previous discussion between Bob and Sanjeev that we academics have been actually proposing the zero trust model for more than 5 years now. I remember 2014 going around with my PhD thesis defense and job talk, just saying, emphasizing how important it is to no longer assume that perimeter-based security is enough and be prepared for when the attacker breaks in. Assume eventually it's going to break in and be prepared for even then. And it's really, really lovely to see that now even the government is pushing for this hard. It's also really nice to see how much industry has adopted this model, is increasingly adopting it. It's very, very exciting. So to explain why zero trust is very important, I'm going to focus more on the technical side of the things, but to explain why technically it's so important, let's contrast with the traditional perimeter-based security. So today, if you have some cloud with sensitive data and you want to keep the hackers out of that cloud and out of accessing that data, what today's systems do is, well, they have perimeter-based security, which is basically building taller and taller walls around the sensitive data. Now, these walls are made of software, complex software, and software will always have bugs. We cannot write bug-free software. We can never do that. That's why the attackers will eventually exploit those bugs and enter to get access to the data. And this is what happened in situations like the Microsoft Exchange server, the SolarWinds, and the many other examples you've heard about. Now, as I mentioned, the zero trust model, and as Sanjeev and Bob also mentioned very much so, is to assume the attacker broke in and be prepared even then. And the nice thing is that the zero trust model has been adopted more and more in industry. Now, very exciting that the government is also recommending it very highly. So it started with blockchains and cryptocurrencies like Bitcoin and Ethereum. They are trying to not have a central point of attack, trying to not have anyone know that if compromised will affect the security of the system. Now, even very, very exciting is in chat. WhatsApp brought the notion of zero trust through end-to-end encryption to billions of users. If the WhatsApp server gets compromised and the attacker breaks in, it's going to see encrypted messages. So it's going to be fine. Now, in this world of telework, even Zoom realized that they have to move to a zero trust model and adopt end-to-end encryption so that if the Zoom server is compromised, then people's video recordings won't be able to be decrypted. They are encrypted. They are basically gibberish and random. So the question is, okay, so how do we go about providing zero trust from a technical standpoint? And I'm going to explain that to you at a high level, tell you some common and very, very useful tools for providing zero trust. And I'm going to take as an example email, messaging, file storage, and sharing systems, because these are pillars for communication, and these are commonly attacked applications where, like in the SolarWinds case, for example, where the attackers exfiltrate emails and sensitive communication. So to provide the zero trust to system, you have to think in a systematic way. You have to think of the server, you have to think of the users, you have to think of the administrators. So let me now show you a set of very powerful techniques that enable providing zero trust with respect to these three components. First, let's contrast with how an email gets sent in a traditional perimeter-based security system. Well, let's say that there's a user on company A, and they're using tools like GCC High, Office 365, G Suite, and others. They're going to take this email, they're going to send it to the recipient's mail servers. It's going to be over a secure channel, but the recipient's mail servers are going to have that email in unencrypted form, are going to be able to essentially look at that email in the mail servers, and then they send it to the actual user's devices. Now, the problem is that if the attacker attacks the mail server, let's say at company B, is going to find all the email for company B. So it's a central point of attack for company B. It gets all those juicy emails that were sent in company B, and that's not good. That's why we hear of all these massive breaches, because there's places that aggregate available emails and information. Instead, one very first step towards zero trust is end-to-end encryption. With end-to-end encryption, the situation is different. The user at company A is going to encrypt the email on their local device, send it encrypted to the mail servers, who are then going to send it further to the recipient's devices. Only on the recipient's devices can the email be decrypted, not in the mail server in the cloud. So the mail server in the cloud has encrypted emails that look like gibberish, and they don't have a decryption key. So if an attacker breaks into the mail server, all the attacker can find is encrypted email that's just gibberish and no key to decrypt it. So even if it broke perimeter security, it got to find those emails that are not useful, cannot read them. The key is only available with the recipients, and the recipients can only decrypt their email and nobody else's email. So that's why end-to-end encryption is so powerful, because only the ends can decrypt, no intermediaries, no server, nobody in the middle, and the ends can only decrypt their own data. So that's a very first step, and this is why the NSA is highly recommending using end-to-end encryption in this age of telework for your communication, various communication applications. Now, another very important step is, let's look at the user side of things. Well, today, in a traditional perimeter-based system, the way a user authenticates is via password. The user shows to the server that it knows the password, and then the server is going to let the user use the service access the files. Now, if the attacker guesses the password, and this happens a lot, right? Because many users don't choose strong passwords, they're hard to memorize, then the attacker is going to be able to access the user's data. Instead, in situations like zero trust and end-to-end encryption, what's much more secure is to rely on cryptographic keys instead of on passwords. So cryptographic key is a long series of random bits that are stored on the user's device. You need a cryptographic key to have access to the user's data. But there's so many of those cryptographic keys that it's virtually impossible to guess them. I actually like to give to my students the analogy that there are more such cryptographic keys than there are atoms in the universe. So the attacker really can't guess them. And without knowing the key, the attacker cannot decrypt the user's data. All right. Now, let's look a little bit at administrators. We've seen many attacks when the administrator, because they have access usually to all the data in a perimeter-based system, they get attacked, their account gets attacked, and then the attacker is going to be able to do the same thing that the administrator can do. And the administrator can do a lot of things in many perimeter-based systems. They can access the whole data. They can add users, reset passwords, and whatnot. And So the administrator is a central point of attack. It's basically a place where zero trust gets violated if the administrator can have access to everything like that. So instead, to go towards a zero trust architecture, what one wants to do is wants to distribute the trust. So instead of one administrator with the power over the whole system, you should split this trust across multiple administrators. The same way you would do with the nuclear launch codes. You'd need multiple of them to authorize a very, very crucial operation. For example, let's say that Alice has lost her key and she needs access to her key. We can't have an administrator know everybody's keys, because that's the place where the attacker is going to break in and get all the keys and get access to the data. Instead, in a zero trust model where you distribute the trusts, you split the key across different administrators. So when Alice lost her devices, she has to call them up or she has to contact them, authenticate, say I'm Alice. And together they can put her key together. And with her key, then she can reconstruct her data. Now, no single administrator alone with piece of a key could get access to data, even if compromised. In fact, you can set the policies to need 2 out of 3 or all 3. All right, so that eliminates trust in any one administrator as well. So we've made a lot of progress. Another very useful feature for zero trust is to verify the identity of people who communicate with you. In today's traditional systems, the internet is wide open. So when you get an email from a so-called customer, it could be from an attacker, it could be a phishing email. And many times users fall for them and do transactions like sending money. Instead, in a zero trust system, you don't want to trust where you're getting the email from. You really want to verify the identity. And again, there's the notion of cryptographic verification. We can really check that whoever is sending you an email is actually who they claim to be. So now if you have people from the outside try to send you an email, they cannot reach you, but also you can implement it such that if by mistake an employee sends data outside to an email that's not inside a trusted community, they're going to get stopped. So these were 4 components for going towards zero trust and very, very powerful security mechanisms. So it was end-to-end encryption. It was using cryptographic keys instead of passwords. It was removing the administrator from being a central point of attack, distributing trust instead, and trusted communities. And I want to say that these things used to be academic proposals and techniques, right? But now they're reality. They actually exist in tools today that are very, very easy to use. Like WhatsApp, for example, for chat, or Preval has all these components for file sharing and for email. So it's no longer just an academic, very powerful security technique. These are real tools that are embedded in existing workflows of users with emails, their operating system, file sharing. So they're very, very easy to use.
Thank you very much, Raluca. I appreciate that. And now let's move towards getting a little flavor for how these tools, these techniques that Raluca spoke about, are now becoming part of compliance programs. So one of the very first compliance initiatives that explicitly, while not calling out zero trust, embedded these principles of zero trust was the section 120.54 from the State Department for storing and sharing ITAR data. So if you wanted to use a cloud service, what the State Department regulations now say is, number 1, don't trust the cloud, ensure that the data is encrypted end-to-end. Second, don't even trust the encryption algorithm because they too could be breached. So only use encryption algorithms that are open and have been publicly verified, and so FIPS 140-2. And then ensure that the cloud service provider has absolutely no access to keys, network access codes, passwords, etc., that enable decryption. So in other words, ensure that there is no trust put in the cloud provider, even the encryption. And yet these simple principles now enable the use of sort of cloud-based systems to be able to go and store and share ITAR data. And then finally, again, these complex principles can be simplified, and the NSA does a really good job. So in the NSA cybersecurity briefing on April 2020, they laid out 9 criteria on what an organization should consider when selecting a secure collaboration service. And it is completely and deeply rooted in zero trust. So I highlight again the points in the aspects in red. You'll see the familiar ones that Raluca had mentioned. Does the service implement end-to-end encryption? Does it use testable encryption standards like FIPS 140? Can users see and control who accesses these sessions? Has the collaborations, the services source code being shared? Don't even trust the code of the organization that you're dealing with. And so what you are seeing over here is, again, an increasing emphasis from the National Security Agency in influencing, compliance and security parameters, dealing with keeping information secure. And it should come as no surprise that it is our understanding that the State Department regulations on ITAR were heavily influenced by the National Security Agency. So with that, we've given a feel for what zero trust is. We've given a sense for it for communication and collaboration systems, but obviously zero trust is a much larger topic. It doesn't just touch collaboration systems, but it touches all aspects of the network. And to discuss those, over to Bob to discuss the implications of zero trust, how it could impact upcoming compliance programs, what are the things that are important to understand, and the challenges that we will face in implementing zero trust. So over to you, Bob.
Thank you. If you don't mind, I might want to put a screen up so maybe I can have that authority. So one of the great challenges here is to move from kind of the where we are to where we want to be. In a sense, the executive order is a quiet indictment of perimeter security. And if that's true as to federal departments and agencies, that's likely to be true as to commercial organizations, including those who are government contractors. And yet, the concept of zero trust architecture is relatively easy to describe, but quite challenging to implement. There is no single technical solution that will get you there. It's a combination of policy and process, training and technology, devices and systems. And the more comprehensive documentation that's come out from the government recently has stressed that zero trust is a proposition to which organizations should aim, but that no one should expect that you can convert existing networks to a zero trust architecture either instantly or rapidly. And you want to find ways to do it incrementally so that the investment is proportionate to the resources and ability of each organization. Now, my view is that encryption is certainly one of the elements of zero trust, one among many. But one of the things that I like about encryption as a part of data loss prevention, digital rights management, is that compared to some of the other aspects of zero trust, encryption can be accomplished, relatively speaking, cheaply and effectively without a huge amount of resource or expertise in an organization. I don't think that Prevail is the answer to every organization's problems. I do think that Prevail can be very helpful to smaller or medium-sized organizations who are looking for ways to actually protect against adverse outcomes by denying adversaries easy access to sensitive data and closing off communications channels that otherwise could be vulnerable to attack. That's very good. But that's not the same as satisfying all 130 requirements of CMMC Level 3. And although it certainly contributes to satisfying 171, it's a partial contribution. That shouldn't surprise us either, because there are 14 or 15 security domains in 171, and there's a lot to cover. Now, I'm hoping that I can get a screen share here, because I've excerpted a couple of useful summaries.
Bob, you have full rights to screen share.
Okay, I'm just trying to get the right document here. Screen 2. I think I've got it. Now, hopefully you're going to see something that says section 10K at the front. Somebody tell me if you see it. EO
Yes.
section, perfect. So, you know, it's fascinating the extent to which zero trust got emphasis in the executive order. In section 3, which is about modernizing a federal system, the executive order says that federal departments and agencies should adopt security best practices. And then it says specifically that they should advance towards zero trust architecture. I think that's a reflection of the painful lessons learned and the risks still present from SolarWinds. It goes on to say that each agency shall develop a zero trust plan with migration steps. I had mentioned that zero trust is a journey, and the executive order, even with its emphasis, says steps. But what I didn't include there was another part of the same quote, namely that each agency is to come up with a zero trust plan within 60 days. On the scale of activities for the federal government, 60 days is essentially no time at all. This definitely speaks to the importance. It also goes on to say that migration to cloud shall adopt ZTA. Well, one of the reasons that makes sense is that when you look at the whole range of assets, capabilities, tools, techniques, monitoring, reporting, analytics that you would want for a fully realized zero trust architecture, well, a lot of that stuff is more easily available and perhaps only available in a high performance cloud environment. And I do know that Microsoft, and I presume that AWS, are making, you know, great investments in bringing zero trust architecture into their commercial products, and as well as, I believe, into their government products. It's also interesting to say, the EO continues to say that CISA should modernize its activities to include cloud and zero trust architecture. I think that's kind of a quiet reference to the continuous diagnostics and monitoring program, the Einstein program, which tends to focus upon those existing network parameters and doesn't really reach out to recognize the federal government's move towards cloud. This is going to produce a big change. Now, I want to go, it's also fascinating, as you can see in this excerpt, that the executive order has this very long definition of zero trust architecture. And that's instructive, but there are some other good definitions out there. Let's just talk about a couple things. It's a model, it's a design principle, and it's a strategy. Nobody can sell you an instant out-of-the-box zero trust architecture. If anybody proposes that, don't talk to them anymore. It does involve, it eliminates implicit trust in any one element, node, or service. I get that. It also should eliminate any implicit trust in any device. That's part of it. And it says it requires continuous verification. Well, continuous verification is a pretty daunting thing, because what it means is that you're collecting a whole range of information from inside and outside the system, potentially including, you know, threat intelligence. And at the device level, you may be looking at where the device is located and the nature of device and whether you have qualified it previously and whether the activity of that device, you know, is consistent with its prior use. I mean, if you think of the data processing, the data volumes, and the data demands, or continuous verification, that's hard stuff. Again, easy to discuss in principle, hard to accomplish. It goes on to say that you get full access, but only the bare minimum. Well, you know, we talked about prevalent encryption, and that looks at access to emails or access to files. You know, fully enabled zero trust architecture is something that looks to data as part of the access question, but other resources within the network or within the enterprise as part of it also. And I'm going to show you a chart that'll describe that further. It says if a device is compromised, zero trust can ensure that the damage is contained. Well, part of that is through use of digital rights management and making sure, I mean, encryption of data is coupled with the key that enables the authorized user to have access to the data unencrypted. So those things come together, as Dr. Popa has described. But you know, apart from keeping people out of or deny data that they should not have in the context of a security risk, another element to zero trust is the possibility that you will decide that individual devices, including remote access devices such as your phone or iPad, or even whole classes of devices, should be denied access, or their access should be restrained are temporarily frustrated. These are all things. And when you think about those kinds of activities, what you're talking about is not just the accumulation of data, but the generation of a policy engine that's going to determine what circumstances should cause which actions to open or close, restrain or report access to resources, including data. And you have to have a lot of information from the enterprise itself as to what it wants to protect with what level of such measures, because these things are necessarily intrusive. Another thing we have to consider is that if you went from 0 to 60 and got to full speed on a zero trust architecture immediately, would it actually be workable? I mean, this is sort of my big question. I see where it's going, but if it becomes an overlay that's impossible to actuate, that essentially denies the enterprise the ability to produce, much less innovate, well, then things have got to change. But let me go on with this definition. It's pretty interesting because it talks about you look for anomalous or malicious activity. Well, essentially, that is looking at the characteristics of the action of the individual device or the individual user and trying to decide whether in light of history, rules, policy, or process, those actions are consistent with what that user should do. So even if the user is properly authenticated, in other words, if their identity and access management matches up, you can have situations in zero trust where what you see of the device indicates that something is wrong, and then you can use that policy engine to restrict control. This is quite important because it actually speaks to some of the SolarWinds experience. There were, if I recall correctly, essentially faked or compromised credentials so that users were able to get access to information and then use it in ways which are unpredicted. So part of zero trust is endpoint detection and response, so that you're looking at the device, the nature of the access, the use that's contemplated, and using continuous analytics and monitoring to see whether there are variations or discrepancies against expected. So all these things, easy to discuss: granular risk-based access, system security automation, data-centric security. Those are great subjects, and that's where we're moving. But it does distill, on the access point, it distills to who, what, when, where, and how. Those are the parts for identity and access management. They contribute importantly to authentication and the decision to authorize particular uses or to close those. Now, when we talk about zero trust capability, here I'm looking at the DISA, Defense Information Systems Security Agency. I sometimes mix that up. Zero Trust Reference Architecture. And they have 7 distinct columns for zero trust: the user, the device, the network environment, the application and workload, the data, visibility and automatics, automation and orchestration. Well, when you read about this in detail, or you look to the counterpart discussion in NIST Special Publication SP 207, you realize that there's some brilliant stuff in there, and that if you could actually do it, it would be fantastic and amazing, and we would live in a better and more secure area. But it is going to be hard, and it's going to be different for every organization. And in fact, when you think about zero trust, you want to be looking at the elements that you can adopt successfully and affordably initially, and then you need to have a plan so that you're able to incorporate, test, and then put into deployment other elements or facets of zero trust over time, so that you're working towards that complete architecture, not expecting yourself to achieve it instantly. So here at DISA, they have these key principles: software-defined networking. That's a euphemism for cloud. Cloud is a software-defined network. It's a gigantic network where the software sets up the logical divisions and controls the access. You can get very granular with that. Data tagging is a sort of, it's not quite a variation on encryption, but what data tagging does is essentially, if I get it correctly, and tell me, Dr. Popa, if I'm wrong, data tagging allows an enterprise to use metadata to essentially inform the system of what user should get which particular access with what rights that could be withdrawn to any form of data that is tagged. I believe that's right. That's another thing that's a great concept, but if you've got, a terabyte of data that hasn't been tagged before, and which is in a flat file rather than an object form, it's going to get pretty hard. Behavioral analytics, this is that thing where I want to monitor what you're doing and where you are and what device you're using and what you're doing with it. And one of the nice things about encryption, is that is that if a lot of these things aren't done or aren't done well or are done imperfectly, if you have effective encryption and strong and secure keys, essentially the data that's most important to you, which you have encrypted, becomes stuff that might be exfiltrated, but it can't be used, it can't be harmed. Now, this is good, but let's appreciate that part of the problem we're trying to solve is not just the exfiltration, compromise, or loss of information to unauthorized persons. We also want to protect other aspects of data, namely our access to it, ransomware, and our assurance that the data is not compromised. And I don't think encryption quite gets there, but there are other tools and techniques which are more effective or included in zero trust, but hard to do. We also have access control, policy orchestration, encryption, automation, end-to-end security, credential, and access management. So let's talk about all of this in the context of present federal government regulations and contract requirements. Many of you are familiar with the DFARS 204-252-7012. I may have even transposed that. I know it too well. It says that you're supposed to deliver adequate security using NIST Special Publication 800-171. That has 110 security requirements, none of which essentially have any particular bearing on zero trust architecture. Zero trust architecture is so big and beyond that, if you have effective zero trust architecture, you're likely to do pretty well on a 171. But 171 doesn't require zero trust architecture, and neither does CMMC Level 3. Now, a question that people might ask is, well, I mean, if this is the direction the federal government is going, are they going to abandon 171? Will they abandon CMMC, and will they essentially push us all to zero trust? No, I don't think they will, because zero trust is, in a sense, it's not new conceptually, but in deployment, it's relatively new. It's too hard, it's too big, it would be too expensive, and I think it's really beyond the present ability of the federal government to demand it of contractors. And going back to what I said about the executive order originally, the executive order didn't say that agencies and department must do it now. It said they have to move towards it. And that's the message to contractors. Learn about it, move towards it, find the elements that you can affordably adopt, find the information that's most important to secure, use zero trust initially to secure that or data or functions. And there is, it does raise the broader question, and then I'll be quiet, we'll do questions, is how do we reconcile let's call it the aging of SP 800-171. How do we reconcile the pace of change of new techniques, tactics, and practices for security? How do we reconcile the rapid evolution and pernicious change in threats, with these static models? It's a really hard question. The compliance says that if there's a static model required, like 171, we got to do it. We got to do it satisfactorily. But there's another consideration for enterprises, which goes, beyond compliance, and that is to the larger understanding of security. And I do think that companies, whether government contracts or not, should be, considering what are their most important, what data is most important, what types of breach would be most consequential to their supply chain, either the people they sell to or the people they buy from. What would be the harm to the public if they were breached, either in loss of data, loss of access, or the like? And if you look at the areas of critical importance, or where the most injury would be done to your business or to the public, and if you start with measures and techniques that will minimize that damage, I think you produce a positive security outcome. It may not match perfectly with the 110 requirements of 171 or the 130 policies and practices of CMMC Level 3. But I believe as an enterprise, you will be stronger, with that emphasis. Make sure your investment produces a positive result that exposes you, your business, your customers, and the public to less harm. Not if you're breached, but when you're breached, or when you know that the breach has occurred.
Thank you very much, Bob, for providing us with a broad perspective of zero trust, but also relating it to the challenges that organizations face. In particular, I think that the point that you made, which has been a very frequently asked question, is, how does zero trust pertain to NIST 800-171 and CMMC? And your answer, if I am to paraphrase, is that no, these two standards don't ask specifically for zero trust. But as with anything, if you have the ability to satisfy the requirements of these, compliance mandates with zero trust systems, it's a decision you ought to consider in the best interest of your company. Would you like to add some more to, this important question on, NIST 800-171 and CMMC, noting that obviously in ITAR, the notion of zero trust is actually firmly embedded in section 120.54. So just one more time from you, because it's a very frequently asked questions. If you were looking at CMMC and NIST 800-171, knowing clearly that they don't ask for zero trust, how would you, think about zero trust and those two technology and compliance standards?
Well, there are some attributes of 171, some controls, and some aspects of CMMC Level 3, which would certainly call upon you to do an assessment and to look at architectures and policy that would improve your security. So the pursuit of zero trust architecture through the various steps of migration, I think, would help you in confidence in satisfying 171 and CMMC. I don't see them at all as inconsistent, as I think that, frankly, I think that good perimeter security is an important start. Many people talk about a hybrid outcome where you do the best that you can with the network within the perimeter. In other words, with your network on premises within a perimeter, and then you add additional protection over time by zero trust tools and techniques.
Right, and I want to add to that point that, so I completely agree that, taking all today's systems and moving them to zero trust is a significant endeavor. But I think what's really helpful is taking it one step at a time. So for example, email, file sharing, telecommunications, video chat. These are things for which we already have tools that are easy to use and easy to deploy to provide zero trust. So now what you do is, for these, you can actually provide zero trust. So for these, you can actually protect all that confidential information that's being exchanged. Now, what's hard, for example, it's hard for databases like analytics or machine learning, data science, right, and analysis. That's hard to move that to zero trust as well, because you have a pool of data and you're trying to analyze it. You want to look at it. So if you look at it, then it's dangerous for the attacker as well. And there's a lot of research, for example, that I'm doing at UC Berkeley, my students in that space, but that's, that's challenging. But when it comes to communications with chat, file sharing, video chat, these things are much easier to secure and easier to deploy. And it's super worth protecting that information, even if you can't protect all the information in the system. There's a ton of confidential data exchange there. And so implementing zero trust for that is much simpler. So I would say the way to achieve zero trust is not an instant overhaul of everything, but it's taking it step by step and doing all the major steps you can do that are currently easy to do.
I completely agree with that. There's a part of me that looks at zero trust and I, would like to idealize, the perfect system that would do all these things. But when you get granular and you look at all of the sources of information and what has to happen with that information in what time span, if you look at all the policies, rules, decisions, and judgments that have to be made by the enterprise as to who gets what under what circumstances, this gets hard. And if you're not careful with some of these techniques, you can generate what are euphemistically called false positives, which means that you're denying people who should have access, or you're cutting off their access when they need it. And the point of zero trust is to protect the enterprise, not to stop it. And I think, so small steps, with a low risk of adverse consequence, with a vision towards where you want to go are important.
Another question that is being asked and has often been asked, and your perfect audience, panel to answer it, is what additional challenges will quantum computing raise, if any? So Raluca, I know you're one of the world's leading researchers on quantum computing. Talk to us about this question that comes on over and over again. And the essence of it is that zero trust systems, the well-defined ones, designed ones, fundamentally, will be using cryptographic techniques to go and implement aspects of zero trust. What happens when quantum computing comes in?
Yeah. So I'm only an expert when it comes to quantum computing meets cryptography, right? Not the general computation and programming and building systems with it. But when it meets cryptography, what happens is that, as many of you might have heard, quantum computers can, in principle, break a number of encryption algorithms, and be able to enable decryption of the data. However, the very, very good news is that we have encryption algorithms that are post-quantum secure. Basically, we have developed already encryption algorithms that are already being widely used in a number of places that will resist quantum adversaries. So let's say you have a zero trust system using end-to-end encryption. All you have to make sure is that you're using one of those, that you're using those encryption tools, those cryptographic tools, as opposed to those that can be broken. And for example, oftentimes end-to-end encryption is implemented via so-called block ciphers using the AES block cipher, which currently is not known how a quantum attacker could break it. It's considered to still be very much safe against quantum attackers. So a lot of the end-to-end encryption, if built upon those ciphers, then it's still secure. Now, one has to be careful when those keys are established, that's when some of the algorithms are vulnerable, but there are others that are not vulnerable. So I would say one has to make sure that their suite of cryptographic tools is that is secure against quantum attackers, and then they don't have to worry about this.
I have a quick comment. Sometimes, and I did this myself, I started talking about, SolarWinds and all the lessons that it's taught us. Well, I mean, SolarWinds does not represent the typical attacker. Far from it. I mean, SolarWinds is at the very far end of the most sophisticated, persistent, and patient attackers. And it was, we believe, the product of a concerted nation-state investment and activity. What enterprises want to protect, of course, is against the whole range of threats. Quantum attackers may occur someday against some people, but not yet. And so, and the same thing is to SolarWinds, a software delivered, broad impact attack with a command and control function. Yeah, it could happen to you. It might have already happened. But there's that whole span of other activities, from the hacktivist to the, to the criminal, to the ransomware, to the ransomware employer. So we want to be thinking about, activities that can protect our most important functions and data, that are affordable and are deployable. We in fact, people have asked me many times, well, I mean, what's the point of 171 or CMMC if it wouldn't do anything against SolarWinds? Well, if SolarWinds is the 1 out of 1,000 attacker, 171 and CMMC might do an awful lot to protect you against 650 or 750, and to me, that's a good outcome.
Yeah, and if you look at a lot of the data breaches today, there's so many of them. A lot of them are much simpler data breaches where the attackers, hit and steal, right? They break into a server, gather a lot of data, and exfiltrate it out. So if that data, for example, were end-to-end encrypted, that would address a large class of these attacks. So I agree, even if you can't go after 100% of them, if you can address 90% of them, the common ones, which are simpler and not as sophisticated, you still make a huge advance.
And there are some really important concepts that are involved in some Defense Department operations and the DoD's use of cloud computing. Comply to connect is something some people will be familiar with. What it and other forms of identity and device access management essentially are looking to create credentials for each of the endpoint devices that's allowed to connect to a network, even before you get authorization to go to a particular data or to go to a resource. It's a terrific idea, but how much does it cost? I mean, what's the overhead of the system? Who is going to manage it? How much does your organization change, and are you able to accommodate that rate of change of people in these new systems? And all of this requires not just investment, but it requires some skilled people, but a whole lot of automation. You know, otherwise, all these wonderfully elaborated processes in the DISA reference architecture, in NIST SP 800-207, I mean, they are wonderful goals, but we have to find ways to make them achievable. And those could be many steps, some of which are small, some of which are big, some relatively inexpensive, and some quite expensive.
Well, Bob, it's some good news, at least on one aspect. Simple ways to do this. There are techniques, in fact, implemented ones right now, where each device has an automatic encryption key associated with it. So, for example, well-designed end-to-end encrypted systems not only have their encryption and decryption keys, but also device keys that are on the system that rotate every 24 hours, and they're automatically designed into the systems, so that also when you authenticate yourself, you're authenticating not only yourself as a user, but also authenticating yourself as a device as well, and only authorized devices can get on. But it's an excellent point that you make. I see that we are reaching at the top of the hour. I wish to thank our distinguished panel of experts over here. Thank you, Bob, and thank you, Raluca, for sharing insights. And if there are follow-on questions, don't hesitate to reach out to us at info@prevail.com. Thanks very much again for your attendance.
Thank you.
Thank you, everyone.